So let's back up for a moment. Let's think about how can we orchestrate the processing of data. And there's a sort of little taxonomy that's worth remembering. So we have a notion of synchronous and asynchronous. So synchronous means that we have this clock that's controlling the flow of data through the circuit. Right? We have these registers that are all run by the clock. So a synchronous circuit is one in which a global clock is controlling the progression of data. An asynchronous circuit, the data just flows through as it can. Okay, whenever one output is ready, it can be processed by the downstream circuit. Okay, and then there's this notion of globally timed. So we have this, a central clock where I'm just going to, beat out a rhythm, and locally timed where we can. The timing is related to the actual processing that I'm asking you to do. If I give you a simple problem, you'll be done sooner. Okay, so we can sort of make a choice among these sort of synchronous, asynchronous, global, and local timed to design the control structure for our circuit, how it's going to process data. Okay, so they're locally timed. Think of it passing a baton. So if we're happening to be running the race fast today, we're able to process the data more quickly. So we can have synchronous globally timed circuits. That's what we're going to build here in 6004. We can do local timing, where we use a little signal to let us know the baton saying, oh, data's ready. Downstream, you can do it. And in fact, we can build asynchronous versions of this. And let me spend a moment sort of seeing how that would work. Suppose you and I want to cooperate, okay, to process some stuff. And there's actually two communications that have to happen between me and you. One, I have to tell you that my data is ready. And secondly, you have to tell me that you've got it, because you may still be busy on some earlier problem, and I have to wait till you say that you acknowledge that you get it. So I'm going to tell you my data is ready by raising my hand. So I'm going to say, here's data. Now, when you're ready, pick a volunteer. Okay, you can raise your hand. Okay, now I know that she has received my data. So that's the first communication. I've transmitted the data reliably because she's signaled when she's got the data. Everybody happy with that? Now, how do I know that she's got the data? Because you put your hand up. How do you know that I know that you've got the data? In other words, what can I tell by looking at you that you've got the data? Your hand is up. Okay, how can you know that you've put your hand up and that I've seen that your hand is up? No, if you put it up and down too quickly, I may not have seen it. I put my hand back down to indicate that I've seen your raised hand, and now you can do what? Put your hand down. So there's these four phases, right, of this sort of, I'm ready to send it to you, you've gotten it, I've seen that you've gotten it, so I signal that by putting my hand back down, and then you can put your hand back down, and when I see your hand go back down, now we're back to where we started, we can do it all over again. So that's how sort of these asynchronous self-time circuits work. What would happen if there were two of you I had to deal with? So let me borrow you as the second person. Okay, so I have data and I'm sending it to two modules. So eventually you both are, so I'm looking for the and of those two signals, right? When you both have it, then I can say, aha, everybody's gotten it. So now I can put my hand down. And at whatever times you feel good, you can put your hand down. Now I'm waiting until I'm looking at the OR of the two signals, and when the OR goes down, I know that both of you have finished your processing, right? So there's a sort of notion, I can build these little pieces of control logic here, okay, that can synthesize, I can deal with as many modules as I want that way, okay?